Hello, I welcome you all once again to my YouTube channel. If you are new, consider subscribing. So we are having this question that is saying, in an experiment to prepare a salt. So we are given a salt that in an experiment to prepare a salt, a runner reacted 3.0 grams of magnesium oxide with 40.0 centimeters cubed of dilute nitric acid of concentration 2.0 moles per decimeter cubed. This is the concentration. Then the first question is saying, write a balanced chemical equation. How can we write a balanced chemical equation for this reaction that is above there? Like I always tell you, I will not only teach you on how to answer these questions, but these questions should give you an idea on how to go about the next question that you may encounter even in your exams. So we are taught to prepare a salt. So if you are told, maybe the first question can be define a salt. What is a salt? So you know that a salt is a compound that is formed when the hydrogen ion of an acid are fully or partially replaced by a metal or ammonium. That is the definition of a salt. So we are told that in this experiment, Elena was to prepare a salt. So Elena reacted 3.0 grams of magnesium oxide with the what? So magnesium oxide was reacted with what? Dilute nitric acid. These are two compounds that were reacted. And we are told to write a balanced chemical equation for this reaction. So magnesium oxide is like this. This is magnesium oxide. I believe you know how to write this. This is magnesium oxide. Was reacted with what? Dilute nitric acid. Nitric acid is like this. This is how nitric acid is, like this. So now, what are the product? What was the salt? What was the name of the salt that was formed? So like this, you know that this one is what? This one is magnesium. Magnesium will react with what? Will react with that. So when these two react together, we are going to form magnesium nitrate. Magnesium nitrate is like this. Have you seen? Like this. Hope no one is behind on this. This is magnesium what? Magnesium nitrate. You know that this 2 is the valence for magnesium. You say plus. What will remain? Hydrogen and oxygen. When those two reacts, what is formed is water. Like this. Have you seen? This is what is formed. So this is, you check. Is this equation balanced? Is this equation balanced? You start now balancing this chemical equation. How do we balance this? How do we balance this? You check here. Magnesium, we've got 1 here. Magnesium, we've got 1. Even there, we've got 1. Oxygen this side. Oxygen, we've got 4. Oxygen this side, this is 6. 7 plus that one, which means we've got 7 this side. So what if we put a 2 there? We put a 2 there. Let us put a 2 there. So when we put a 2 there, hydrogen 2 there. Nitrogen, have you seen this 2? Even there, nitrogen is 2. So meaning that just by putting a 2 there, this chemical equation is balanced. So just needs to put a 2 there, then this chemical equation is balanced. So these are some of the things that you need to do. These are procedures that you need to do. So initially, to summarize balancing chemical equation, you just need to balance this one, hydrogen or oxygen. You discover that the chemical equation will be balanced. This is what you need to do. So I've balanced it. Make sure if you don't know how to write chemical formulas, review that video. I've made that video and writing correct chemical formulas. That's why I was so fast on this one. So now we go to the next question. So a balanced equation is like this. Together with a 2, you need to put a 2 there. This is a balanced chemical equation. We move to the next one. Calculate the number of moles of magnesium oxide. So how can you calculate the number of moles for magnesium oxide? You want to calculate the number of moles for magnesium oxide. So where is magnesium oxide in the question? Magnesium oxide in the question is just here. So we are told that what? 3 grams of magnesium oxide. So 3 grams of magnesium oxide. We are given grams. Then we want to calculate the number of moles, which means we are going to use that formula that has got masses, because we are given mass here. This is the mass that we are given. So I'm going to use that formula that has got mass. So what am I going to do? What I'm going to do is this is what I'm going to do. I know that number of moles is equal to, you say mass, this is the formula, mass over what? Over molar mass. This is the formula that we get to use, over what? Molar mass, which is equal to, what is the mass? We are given that it is 3.0 over, what is the molar mass? Molar mass for what? Magnesium oxide. How do we calculate the molar mass for magnesium oxide? Magnesium oxide is like this. I'm going to write it here. It is just like this. So you say, how many atoms? 1. 1 times what? 16. 16 is the mass number for this one. You move to what? Magnesium. 1 times, what is the mass number? 24. So here you are going to get 16 plus what? 24. What answer are you getting here when you add 0, 1, 3? You are going to get what? 40. We are going to get a 40. So it is 40 what? 40 grams per mole. This is the what? This is the molar mass for what? Magnesium oxide. So this 40, I'm going to write it there like that. This is what I'm going to do. So I say this is now equal to, what is the answer when I divide there? So when I divide there, what answer am I getting? 3.0 divide 40. What answer am I getting? I'm getting, this is the answer that I'm getting, 0.075. I'm calculating the number of moles. So I put what? I put moles. So this is the number of moles for what? Magnesium oxide. As simple as this. This is what I need to do. These are some of the things that are supposed to be done. So make sure that you calculate this. Make sure that you understand this part very well. This is the easiest way in which you can answer this question. So we now move to this one. For the dilute nitric acid, how can we calculate the number of moles for the dilute nitric acid? So for the dilute nitric acid, what are we given? You go back to the question. You check what is given. You cannot use this formula when there is no mass involved. So what are you given? We are given that 40.0 centimeters cubed of dilute nitric acid. Obviously, we are given the volume and the what? And the concentration, which means that you are supposed to use that formula that is under concentration for you to calculate the number of moles. So we know that this is what we know. We know that concentration is equal to number of moles over what? Over volume. Have you seen? This is what we know. Do we have the concentration? Do we have the concentration there? Are you given the concentration? The answer is what? Yes. Concentration is what? We are given a concentration of 2. Have you seen? 2.0 moles per decimeters cubed. The volume is what? Decimeters. Pay attention to that. So concentration, you put 2. So you say 2 is equal to, N is what you are looking for, over the volume now. Have you seen the volume? This is molarity. The other name for that is molarity, where concentration is expressed in moles per decimeters cubed. So what I'm going to do is this. This is what I'm going to do. I convert 40. So I'm given what? I'm given 40.0 centimeters cubed. So I'm not supposed to use this because if you check the units which are there for volume is what? Decimeters. So I divide this by what? 1000. This is what you need to do. So if you want to convert from centimeters cubed to decimeters cubed, you need to divide by 1000. So you say 40.0 divide 1000. What answer are you going to get? The answer that you are going to get will be 0.04. So this is the volume. That's why I've even written it here. This is the volume. Volume there, number of moles over volume. So here 0.04. So converting that, the answer that you get when you convert there, this is the answer that you've seen. We've gotten 0.04 decimeters cubed. So this is the answer once we convert. So I've converted, I put it here. Then I say over 1, then I cross multiply. N times 1, it is N, which is equal to. So what is 2 times 0.04? What answer am I getting? So what answer are you going to get there? So number of moles is equal to, so you multiply 2.0.04. What answer are you going to get? You are going to get 0.08. These are what? These are moles. We've answered this question. Have you seen? So I've calculated the number of moles for what? For magnesium oxide like this. And I've also calculated the number of moles for nitric acid, as simple as this. So these are the two answers that I've gotten. So this is what you need to do. Have you seen? I've answered these two questions. So these are the two questions that I was taught. So this is the number of moles. How did I know that I'm supposed to use this formula? Mass was given. But whenever you see volume given and concentration, you need to be sensitive enough. You discern, you know that, okay, I'm given volume and concentration, which means you use the formula for that of concentration. This is what you need to do. And the other question that may come is that now determine the limiting reagent. How can you determine the limiting reagent in this case? How can you determine the limiting reagent? So the way in which you can determine the limiting reagent here is very simple. It's very simple. So the way you are going to determine the limiting reagent is that this is what you are going to do. This is what you are going to do. You know that the limiting reagent is that reagent that finishes first before the end of a chemical reaction. And how do you determine the limiting reagent? You calculate the number of moles for the two reactants. And this is what we've just done. We've calculated the number of moles for these two reactants, this one and this one. These are the answers that we found. So now, the one with the lowest number of moles, that is the limiting reagent. In this case, what is the limiting reagent? You just, therefore, which one has got the least number of moles here? It is this one. Have you seen? It is 0.075. 07. Here it's 0.8. Have you seen? So this one has got the least number of moles. Therefore, it is the limiting reagent. Therefore, magnesium oxide is the what? Is the what? Limiting reagent. This is the limiting reagent. As simple as this, you are done. That is the limiting reagent. This is what you need to do. So these are things that you need to do. This is what you need to do, even in an exam. So this, I believe it has helped you. Whenever you see such a question, you'll be able to answer. So don't forget to subscribe. And if you are looking for tuitions, you can contact me on WhatsApp using this number. This is my number. We offer tuitions at an affordable fee. This is my number. You get to WhatsApp me on that number. We do over mathematics, chemistry, and physics, all levels. Thank you so much. Don't forget to share and let me know where you are watching me from. This is your tutor, Addison J. Zulu Tutor.